For my project, I wanted to do something over domain and range. I looked at the data that I had from this year and last year and found that this was one of my weakest areas. My students were one question behind consistently from the rest of the school and district that I'm in. And so I wanted to make some significant changes to what I did for domain and range for next year. To do that, I'm using Desmos, and as you see, it says that I have a copy of Domain and Range Practice. I took a lesson that Susan Von Oy had already made. It was 22 slides, and then I took that and I modified it to fit what I'm trying to accomplish, expanded it, and made it into 44 different slides. But this would be the bulk of what we did in a lesson. And so my goal at the end of this lesson is that students would be able to define the domain of a relation using inequalities, that students would be able to define the range of a relation using the inequalities, and that they would do something they've already done, which is define whether it's a relation or a function, but because of the domain and range, be able to see whether or not it's a relation or a function. And so we're going to dive right into this. I would start the class the day before by telling them that we would start in a computer lab the next day. So that was something that would have to be taken care of before. And then to get the kids engaged, when they walked in, I would assign a computer to each one of them. And our computer classrooms on campus are kind of cramped. And so I want to start that day by giving the students my expectations of how they should act in the computer lab, but then use that, the fact that it's cramped, to talk about personal space. And so I've got some guiding questions that after I've given my expectations and discussed personal space, that I would ask them things like, do you want the person next to you in your space? And nobody wants that. Nobody wants somebody in their bubble. And then I would tell them that they need to define where their space is by putting up some barriers. And then I would ask them a really leading question like, would you define your space by listing all the points that make up the section of your desk? And some students may say yes to that, and some students might say no. If they say yes, I want to show them how silly it is to have to point to this spot, and 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 have to get them all on their desk, that it wouldn't make any sense. And so when a student says no, or if a student says no first, instead of having to point it all out right away, I would say, that's exactly right, but why would we not want to define your space just by all of the points? And get them to say that it just doesn't make sense that there's too many points to be able to list them all, that it would be easier to put up some sort of a fence or some sort of a barrier. And then I would use that to transition into what we're talking about that day, and talk about how relations and functions, something that they will have already learned by this point, also need barriers that define where their space is. And so this year I tried to discuss cropping a picture with them. And I saw more success this year than last year, but I think that maybe this personal space thing may make it more relatable even to them. And so after we've got all of that established and they've been logged into the computers now, I would have them go to Desmos. And I would start by talking about what domain and range are. And one of the things that I do that students do gravitate well to is that when I'm explaining domain and range, I tell them that they talk about the two different variables. And I always ask my students, what is the main variable that we use in algebra? And almost always their answer is x. And so I say, absolutely, x. So our domain is talking about all of the possible x values. And then I tell them even more generally that it's all of our possible input values. And so I would start by having them do this and asking them, is this a function or not? And yes, it is a function. They would need to explain their thinking, and on most of these slides, they're going to explain their thinking. Then it goes on to tell them that the same function has been graphed here, but it's got this orange shaded region around it to give it its own personal space. And so then I would ask, is this domain or range? And so they would pick and have to give their explanation again, that because this is using the x-axis, that it would be domain. It's the main value there. And then a new function here, and I would ask them, would the shaded region be the domain of this function? Well, in this case, it's not, because it actually takes up too much space. And so again, I'd ask them to explain that in their thinking. And so because it's taking up too much space, how can we fix it? And with each one of these, when they share it with the class, not only are they sharing their answers, but they're going to get to see what other people are answering as well. And so I have each one of these input questions set up to be that way. And I just have several more problems that are going to teach them how to type in an inequality to show them how to set it up. And this was something that the original activity had in it, and I thought was an excellent idea that was recommended by Dr. Alvarez. And then it comes here and it allows them to actually change these sliders. And because I've already been playing with it, it started off already where it needed to be. But this would be what it starts off, something like this, and they have to drag it so that the domain and range are set up correctly. And so then on the next slide, it's going to start asking them to actually write the domain and the range. So they've now been able to fit it within the two sliders, but now they're actually going to have to be careful and write it out using inequalities. Again, inequalities is something that they have already talked about when we start talking about domain and range. And so we get several of these domain challenge problems where they're going to fit it in. But here it's going to start to introduce piecewise functions. And again, this is not something that we talk about a whole lot with in Algebra 1, but it's more about just getting them to understand the difference between domain and range. And so I don't want to just use the things that they're going to see over and over again this year. This will give them a broader view to talk about something that's piecewise, and it's going to allow me to do some more things like talking about something that is not a function, which we get to in this next problem here. And so this function is very similar to what we saw a second ago, except this time the domains overlap, and this is no longer a function. And so it'll ask them to define the orange section, and then ask them to define the blue section, and then ask if this would be considered a function. And no, it's not a function. Most of my students are already familiar with the vertical line test, and so they could tell me that when they explain their thinking. But then I want them to think about, because it's not a function, do they really need two different inequalities? And for the domain, they don't need two different inequalities. Really, for the range, they wouldn't either. But when they answer this, they again have to give their thinking. And on the next slide, they now can just give me one big domain that encompasses the entire piecewise function. And so this whole several question process was specifically meant to lead them into this realization that even though this thing is not a function, or because of that overlap in the domain, they're actually able to use one inequality rather than two, like they had to in the previous problem. From there, it allows them to play with other problems and still get more domain practice where they can set these up on their own, and they get to add more regions to it. So these are just more problems getting them to write multiple inequalities for the domain, and then we move into the range. And the range is going to use a lot of the same functions that we just did for the domain, so that they can see, well, I just talked about this function, but now I'm needing to go vertically instead of horizontally, and get them to relate that to the range. And so when I talk about range, every year I have a student tell me that range is the difference between the highest value and the lowest value, because they're thinking of some of the statistics things that they learned when they were in middle school. And so I don't want to just brush that away and tell them that that's not what range is. I just want to get them to realize that this is a different type of range, but I still want to relate what they already know, build on that previous knowledge. And so what I tell my students when we talk about range is that it is the lowest value to the highest value. And so they still get to see some of that. And a lot of that would already be introduced before they began this, at least talking about what domain and range are, so that as they're exploring the concept here, they're getting to become more comfortable with it, but they wouldn't be able to become more comfortable with it if they didn't know what it was to begin with. And so then they begin writing this, and I've given them a little hint there that range does not pertain to the main variable. And so that's a hint that they should be using y now in their range instead of using x. And so just several problems like this again. And now we get to a problem where the highest point doesn't occur at an endpoint. And this is something that my students have struggled with every year. And this is one of the things I really liked about this program, or this activity that Susan had already made, that it has a problem like this, that it specifically talks about this highest point not having a closed dot, but that every point along the path is considered a closed dot. Now, hers didn't actually cut off like this. I still wanted the double-sided inequality for now, and so I did make sure to edit that. But it still keeps the same idea of what she was trying to accomplish, which was to get students to realize that every point along that path is a closed dot unless you actually see the open dot. And so from there, they can get some more of these range challenge problems that are just like the domain ones, where they can still add in new range barriers here. And then they start writing them out. Now this one is, again, where something is different. And so this is what they originally saw. And in this new problem, it is going to be different because this doesn't end. So whereas before we had a graph that ended, this one continues to go on. And as you zoom out on this graph, you would see that the graph actually just continues forever. And so it asks them how it's different and what is the difference, how this might affect the domain and range. And so here I actually gave them the answer because I wanted them to understand what was different here, that because of this last piece, that we would only have a one-sided domain and a one-sided range when we wrote that. And so this is actually where it would end. And the rest of these problems are meant to be sort of part of an exit ticket. So these are just to kind of test to see if they really understood what they were getting at. And now these last 5 problems, it tells them congratulations, they're done. But these last 5 problems wouldn't actually be a part of this Desmos activity. Instead, these would be the full-on exit ticket, and I would take these and add them into Canvas, which is the learning management system that we use on my district, and do a Canvas quiz. I would have several different graphs, just asking what the domain and the range of the function was, and whether or not it was a relation. And I would have Canvas randomly pull some of these questions so that none of the students were getting the same thing, but that they were having this exit ticket on the way out. And so that's my project. I hope that you understood it, and it's something that maybe you could use in your classroom too.